So here's the problem that we have. Calculate the volume of ammonia in liters at 720 degrees, 29 degrees centigrade and 4.5 atmospheric pressure. And this ammonia is required to react with 80.64 grams of oxygen in the reaction. The reaction is given over here. 4 molecules of ammonia in the gas phase reacts with 5 molecules of oxygen also in the gas phase to produce 4 molecules of nitric oxide in the gas phase and 6 molecules of water also in the gas phase. And it is given that the R, which is the molar gas constant, is equal to 0.082 liter atmosphere per Kelvin and per mole. So as you can realize that we have to use the molar gas constant, and we know that the equation is PV is equal to N time R time T, where P is the pressure, and over here it is given 4.5 atmospheric pressure, so we can write that. That is given. V is the volume that we need to calculate. So this is the unknown. The R is the molar gas constant. So R is equal to 0.082 liter atmosphere per degree Kelvin per mole that we have. Is another way of writing the same equation that we have. So let me write the 0 over here. So we have the R. The T is the temperature in Kelvin. The temperature that we have is 729 degrees centigrade. So we have to add 273.15 to get the value in Kelvin. Let me get that value, which is 729 plus 273.15, and that is equal to 1002.15. So that is equal to 1002.15 degree, and this is not the degree, that's really in the Kelvin. So let me remove that, and then is the temperature in Kelvin, right? So we have that value. So the N is the one that we don't know, so but we can calculate that. The N is the number of mole of the ammonia that we need to get, and that will be obtained from the amount of oxygen is given is in grams. So it is 80.64 gram of oxygen that is going to react with the ammonia according to the equation that is given over here. See the 4 moles of ammonia with 5 moles of oxygen. Now we cannot convert grams directly to the grams or moles of ammonia. So we need to convert the grams of oxygen to the moles of oxygen. And to do that, we'll use the factor, the 1 mole of oxygen is really 32 grams of oxygen. So now that we have the moles of oxygen, we can convert that into the mole of ammonia from the relationship that we have in the equation, which is 5 mole of oxygen reacts with 4 moles of ammonia. So now that we have this relationship, we can really cancel some of the units that we have. See, the gram of oxygen cancels out the gram of oxygen over here, mole of oxygen cancels the mole of oxygen here. So we are only left with the mole of ammonia. So now with that, I can really write down the amounts, which is 80.64 over the first one, and then we have the second one 1, and the third one is 4, and in the denominator we have 32, and then we have 5, and the unit that we have is the mole of ammonia. So let me do this calculation. Let's get the calculator and clear up the first one. So we have 80.64 0.64, it is not right, 80.64 times 1, which is going to be the same, times 4, then divided by, let me put that in the parentheses, 32 times 5, close the parenthesis, and that is equal to 2.016. So let me have that 2.016 mole of ammonia. That is the amount we're going to use in the equation. Now that we have all these parameters, let me put those in the equation. We have this in the PV to nRT. Using that equation, PV equal to nRT. If we do the cross multiplication, we put the P underneath the nRT on the right side, then we have the V is equal to nRT divided by the P, and we have the N to be, let me put a line over here, 2.016 mole, okay, then R is equal to 0.082 liter atmosphere per Kelvin per mole. Then the T, and the T that we have is 1002.15, and the unit is K. In the denominator is the P, and the P is 4.5 atmosphere we have. So 4.5 atmosphere. Now we have this equation, and we can remove some of the units. The mole over here will cancel out the mole over here. The Kelvin is going to cancel out the Kelvin over here. The atmosphere in the denominator will cancel out the atmosphere over in the numerator. So now with those, let me put this number V now therefore is equal to 2.016. Let me put a line over here, and then we have 0.082, then we have 1002.15, and the unit that we have is really the liters, so I put the letter over here, and in the denominator we have only 4.5, right? So let's use the calculator to do this calculation. Now let me clear that. We have 2.016 times 0.082 times 1002.15, all the 3, and then divided by, let me put in parentheses 4.5. I didn't need to put in the parentheses, but I did. But that is equal to 36.81. So let me do that. That is equal to 36.81 liter. So that is the volume that we have. So volume of ammonia is equal to 36.81 liters. Now this is without considering the sig fig in the calculation that we have. But if you go through that, you will see that the 4.5 atmospheric pressure is the one that is the lowest number of sig fig. And the other ones are the 4 by 5 is really the relationship that we got from the equation. So none of those will count. So we really have to express that in 2 sig fig. So this we can do is at say 3.7 by rounding the 8 times 10 to the power 1 mole of ammonia. So that really would be the answer for this particular problem.